I did a post to Practical Machinist. By the way, the date on this post is March 12th, 2015. I said, anyway, it's case closed for this particular event, but you can bet your life that I will be installing a better battery and battery monitoring solution of my own design within the next year. Anyone interested in one? I was marketing it already. And I started designing my battery board. And of course, I was doing it slowly because it was a lower priority now. And on February 23rd, 2016, so roughly less than a year, I posted the following. Well, it looks like Haas came out with a battery replacement kit, which does exactly what I described was needed. Now, did I have anything to do with Haas coming out with that battery kit? No idea. But you know what I did? I wrote the check and I said, give me one of those. So I got it as soon as it came out. You see a picture of it on your screen. It's in the thumbnail. And I installed it on the machine. And I have one right here. And what it is, it's very simple. It's battery holders for 2 batteries. These can be type 123 batteries. And on the board, there are 2 diodes. Okay. And these are, without knowing, I know they're Schottky diodes. And it combines the 2 batteries into one output minus a teeny bit of voltage on the order of 0.3 volts. And off it goes to the motherboard. So they came out with that kit, and they came out with instructions with how to remove the battery from the motherboard, something I was already good at, how to install the kit, where to install the kit, because they included Velcro on the back so you could stick it somewhere. And I did all that, and my Haas TL1 was not only back up and running, but it was back up and running with this backup system. Now, one of the beauties of this backup system is that you could take out one of the batteries, replace it, take out the other battery and replace it, and you probably will not lose voltage going to your memory. Although it's still recommended that you do it with the power on. Also, you get twice the life out of the battery because you have 2 of them and they are diode combined. Okay. You cannot take 2 batteries and just put them in parallel. By the way, this is a bad thing. I'm speaking professionally as the former battery guy. So this is a really cool thing. I think I spent $100 and something on it back in 2016-ish. And I think I just bought this one for not much different. I think it was a little cheaper, actually. And that was, I never went to Haas and said, hey, did you get the idea from me? I don't care. I think it's what the market needed. So we're at the bench, and the goal now is to figure out how to connect the Haas battery pack to this FANUC custom battery. And we're going to take this apart and connect the wires to the connector. Here's the connector. Pretty industry standard looking. And it's loose in the housing, which is a good sign. And this is designed to go down into the FANUC control and snap in. It's got a very nice snap. I mean, it's a nice design, but it sure wasn't made to be, simple or cheap. Okay, so the first mission is let's get this battery open. So we'll set this guy aside. Now, I did a little examination under the microscope of this nice molding and looking down these holes here, and I think I discovered something pretty nice. If I push here, look what happens. It pops open. That's a snap. So let's see, I should be able to get maybe something on the other side opened up. So there's your battery, a max cell. And let's see, how does it work on top? It's simpler than I thought. So let's have a look.
Lovely. This is not exactly going to be hard. So here's our lithium battery. Let's see if we can get that guy out. He might have a little adhesive in there. Oh, nope. Watch. Hang on. Nothing up my sleeve, folks. There it is. Set that aside. Take a look at this gorgeous injection molded part. All right. Put that aside. Let's see what this guy is. Okay, so welded tab to solder. Welded tab to solder. Let's confirm that red is positive. There's positive red, check. Negative black, check. And there's our wires. So I'm going to cut these wires off, set aside the battery, and then we're going to attach this cable, maybe with some heat shrink, and feed it up through this molded housing, and I think we should be good to go. Please stand by. On the PFG Live, we had talked about the fact that a battery's open circuit voltage is no indicator of its charge. So here's the old battery, and let's just measure it. 3.14 volts DC, and the label says 3 volts. This should be a pretty good battery, but it was in use for at least a year, if not a couple of years, and its date code is 2008. So this was the factory original battery. So it looks like I have plenty of room where the battery was to form a strain relief. And I also have plenty of room to come in here with a cable because of this cutout. This is going to be actually quite pleasant. So Haas put this label here that said authorization to ship, probably something like void if seal broken. Yeah, void if seal broken. That was useful. So their treatment here is decent. They've got a strain relief. They've got a wire tie as a strain relief, etc. This is fine. This is the wire we have to work with, and this connector is going bye-bye. We'll leave a little bit on the connector in case one day it becomes useful, which is unlikely. I think we're going to go with 2 short pieces of heat shrink individually because this is going to be hidden inside of that box and we want as much flexibility as we can get. So I think that's how we're going to go here. Just remember, engineering is not pretty. You could make the argument that this is not engineering, this is technicianing. not argue with that. I think if more electrical engineers were technicians first, they would design better. Red, red, black, 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 black. Just wait until it goes ow. That's good enough. That's it. Aha. So this is a really excellent lesson right here. This connector, if we try to put it in this way, the wires hit the plastic. But if we rotate 180 degrees, connector goes right in. And this is the perfect example of poka-yoke, which is basically you can't screw it up if you do it the right way. Excellent design. And that's basically it. The wires are going to come right out the side. We have to think about a strain relief. I think we're going to go for some adhesive. So I'm going to use my clamp. I'm going to clamp this, and then we're going to use some UV curing adhesive. Looks good. Okay, we got the UV source warming up. So we have a choice. We could use cyanoacrylate here or the UV curing adhesive. I like the UV curing adhesive because I don't want to get accelerator everywhere, and the UV curing adhesive is much more controllable. This is a big fat needle for Loctite 3525, which is one of my favorites. Good, looks good. Another exposure. By the way, I am closing my eyes for this. I've done this a zillion times, so if I point it where I want it, close my eyes, and then open my eyes when I'm done, I know that's going to work. That's done. Now you know why I love UV curing adhesive. What was just a bunch of spooge before is now solid. Lovely. Okay, I like that. Yeah, that's perfect. I'm going to give it one more hit with the UV. And we should be done. Nice. Okay, so next, we'll move this out of the way. Oh, before we forget, we'll retract the plunger here. We'll wipe the needle and put it in a vertical position elsewhere on the bench. And now let's close this baby up. So this should go this way. I can't emphasize enough how pleased I am with the this design and the fact that we can't put this connector in backwards. Came out really nice. And this beautiful snap together design should also be very cooperative. Almost a little too cooperative. There we go. So theoretically, we're ready to install this. So before we can put this in the machine, of course, we have to put batteries in it. So these are Surefire lithium batteries. I use them in my flashlights. And these are not new. These are 2018, but they are, you know, fresh as the day they were made. So we're gonna insert one here and one here. Let me grab the little clippy dookuses that Haas recommends. Here's the clips that Haas provides. And they clip into the bottom of the battery holder. So there's a recess in the plastic. 1, 2. And another one. 1, 2. Nice. So if at the top of this PC board, there's a little black and red connector, holes for a connector, and we're just going to use that on our voltmeter and just double check that we're getting the voltage we think we're supposed to get. Let's go to the voltmeter. Now at this point it's pretty important not to short out the battery terminals. We got them backwards, but it doesn't matter. 3.228 looks good. Now we're ready to go in the machine. Here we are at the Sharp VMC, and we're about to put our new battery in. So first, an overview. The control panel sits like this, and it has 2 screws that hold it closed, and then it unhinges. Now, the power is on. We're going to be careful. Kids, don't try this at home, except, you know, for the part where you actually try it at home. This is what the back of the panel looks like. And right here is where our battery goes. And you can see the back of our current battery. So we're going to pop this guy out. And now the question is, where are we going to attach our backup board? So a logical place might be right here, but we could also put it right here. I think we have enough cable to go over to that. My choice is right here. So I'm going to grab the piece of Velcro that's on the back of the Haas board, and I'm going to attach it right here. So the Velcro has been attached, and I should point out that this is actually Velcro, a New Hampshire company, but I digress. So we're going to take our backup board and stick it right here. There it is. Good and tight. And here's our connector, our former battery housing. And here's the interesting question. What happens when we take the other battery out? So once again, power is on. System is up and running. And we're going to remove the battery. We might get a low battery alarm, which would be a great sign. Hey, we got a low battery alarm. Let's put that over here. And now we're going to take our new battery, connector on top, snap it in. Oh, we got to hit a reset. So, low battery level. Hit the reset. Totally happy. Okay. This wire seems pretty happy where it is. I don't think we need to do anything to it. And now it's just a matter of close it up. But there you go. I am very excited about this solution. This solves a pretty major problem in that we can now use off-the-shelf Type 123 batteries available from multiple sources. This one is from Surefire. It's a Type 123. There's another type of battery that will fit right into the same exact physical spot. I don't remember the name of it, but you can get Type 123 batteries from every major battery manufacturer. The Surefires I bought because I use Surefire flashlights, and they're not expensive. And we're done. I'm going to button this up. So we're getting ready to change out this label, but fun trick. Remind yourself which wrench you need. Next time you have to get in here, it'll save yourself some time. See you next year.